about how frequently you move each day. How many steps you take, how many times you pick things up and hold on to them in your hands, how many times you sit down and then stand up again. Now imagine how much more difficult your daily life would be if you needed someone to help you perform all of these tasks. That is the struggle of people living with Parkinson's. Parkinson's disease is a debilitating neurodegenerative disorder that's characterized by hallmark motor deficits such as a shuffling gait instead of normal walking, resting tremors and shaking, making it really hard to pick things up and hold on to them, and muscle rigidity or stiffness, making it really hard to move or sit down and then stand up again. Now, Parkinson's impacts about 2% of our senior US population, with over 60,000 new diagnoses being made each year. People with Parkinson's have a hard time moving because the disease causes their nerve cells or neurons to die in a region of the brain that controls movement called the SNC. Now, unfortunately, we don't know how or why these neurons die, and this has resulted in our current treatment options serving as a Band-Aid rather than an antidote. Our treatments can help you move better, but they can't stop your neurons from dying, and they can't stop the disease from getting worse. Now, a large part as to why we don't know how or why these neurons die is because the animal models that we use to study Parkinson's haven't really been able to reflect what happens to us in the human disease. So for example, all of our Parkinson's mouse models represent inherited or hereditary forms of Parkinson's. But Parkinson's is largely not a hereditary disease. It's predominantly age-related. So that's where my research comes into place. Our lab created the first mouse model that actually mimics age-dependent Parkinson's, just as we see it in humans. And we did it by targeting this protein called RGS6. So we discovered that RGS6 is really important in keeping these SNC neurons alive, and that neurons that lose RGS6 die just as they do in Parkinson's. Even more interesting, when we look at the brains of human Parkinson's patients, their SNC neurons have lower levels of RGS6. So now what my research is doing is I'm taking these mice that don't have RGS6 and get Parkinson's as they age, just as we do as humans, and I'm adding RGS6 back to their brains before or after they develop Parkinson's to see if I can prevent and or cure Parkinson's. So by targeting RGS6 in these SNC neurons, we can better improve our current therapeutic options for patients and continue to move forward in movement disorders. Thank you.